Here's my review of the Orient Power 12 volt 230 amp hour battery. It came packed in this box. Actually really well packed. It had foam insert inside 2 layers of cardboard, so it's really solid. Somebody'd have to really run over that box to damage the battery in transit. And it came with this booklet here with some instructions. You can get it out of the box here. It came with this. It's also online. And it also came with a line drawing of how the internal sensors are hooked up to the BMS, which is nice. So there's not much to it. Solid, nicely painted metal case. And there's some indents here. Not super deep indents. You can get your fingers in there just on the fingertips, but makes it easier to move around, but you might need to get some help because it weighs, I think it weighs about 30 pounds. There's all the specs we can look at later. But anyway, it also has these two caps to cover up when you put your wires on. They have some indents in here. See the little indents, and they just snap in there, and then they can move either any direction you have your cable. So those are nice, and the terminals are very nice too. They're pretty solid. And you can get inside this battery easily if you ever need to service it or just want to look. There's some 3 they're hex screws, 3 on this side, 1 on the short end on either side, and then 3 on the back. So these are 2.5 millimeter hex screws. So I'll take them off and open up and we'll look at the BMS. And for full disclosure, I got this, I paid for this, but I got a substantial discount. And they wanted me to do a video review on it, which I'm going to do. I would have done anyway, but I don't have to get it pre-approved or anything like that, so I'll say whatever I see in it, truthfully. And I do have some other Orient Power Jackaper batteries. So those are 48 volt. So this one's their new 12 volt. Oh, one thing I forgot to mention is there's this button on the side here. This button is turns the BMS on and off, and disconnects the battery too. It comes out like that, and you click it, it recesses in a little bit, see? So it's on when it's pushed in, it's off like that. Okay, I have the top, all the screws out, and of course whenever you open these things up you want to use some caution because there's a lot of energy in here. I'll point out some of the things. I've had to look at it before. Here's the BMS on top, and it's labeled too for the here's all the sensors in there. You have your balance leads, and trying to read the label, Bluetooth modules here on the side. I hope the lighting's okay. And then there's the power button, which is this one on the side. Here's the power button that turns the BMS on and off. And then these other ones are the temperature sensors. And You can see what I noticed is the quality of the crimps are really good. You can see it was really crimped on there well. Of course, heat shrink. Looks like good thick heat shrink. And there's a big, really large heat sink down on the bottom of the BMS here. I don't know if you can see that. And my flashlight in there. And then down below you can see the cells. And I'm not going to take the BMS out right now because it's all calibrated. They say it's all calibrated for the state of charge as it comes. And if you disconnect the wires, you're going to have to recalibrate it. And I don't want to mess with it right now. And plus, you'll also have to, if you ever take it apart, you have to make sure you do the right torque settings on there so you don't over tighten it and turn something you don't want to turn, break something. You want to have them tight enough. You can see from the factory, it looks like when they torqued them, they put some paint on there, some red marker or paint on each screw, probably just to make sure that they didn't miss any, you know. So whoever the assembler, you know, if you're doing hundreds of these a day, you might forget to do one. But if they torque it and put the paint on there, they know it's done, and they know it hasn't moved either since they torqued it. And this is the negative to the BMS, and it's a bar. It's a solid bar, which is really nice. Instead of having a cable, they put on a solid bar on there. And then over here is the positive connection from the battery, so they're all in series. And there's the negative to the BMS, and then it goes through the BMS to the negative lead on there. So it looks really well built. I couldn't find anything to fault on it. Oh, the wire is 2 gauge wire, so a pretty good heavy wire. It has to be because it's supposed to be able to carry 200 amps. And it's real flexible wire. It feels like silicone coating, so good quality. And like I said, that steel case is solid. It's not flimsy metal. So looks good inside. I'm gonna put the top back on and then we'll look at the app for it. So first impression's pretty good. Let's just quickly look at some of the specs on this battery. Right now, this is looking at the US Orient Power web page, and it's $700, listed for $700 now. 230 amp hour, and they say 7-year warranty, 8,000 cycles lifespan, and their thing is the low temperature cut off, so if it gets too cold it won't charge. High temperature, same way. And it's got the usual other BMS features like overcurrent and short circuit protection, and it's got balancing. And then the manual is here. That's like the paper one I had that came with it, although this one online is now fixed, because one thing is that Orient Power is you can get in touch with them and they're responsive, because I pointed out some misspellings in the brochure or in the manual that came with it and the one they had online, and they've already fixed it online. So the next time they print the manual, they'll fix the spellings too. So it shows that they have some care about being professional, because a lot of these words in this section were misspelled, so they corrected them, and should be a lot better. So it has an app, the Bluetooth app, I'll fire that up and we'll have a look at it. I was going to look at some of the specs here real quick though. So 230 amp hour capacity, 2,944 watt hours, almost 3 kilowatt hour capacity. Self-discharge rate, typical 3.2 LiFePO4 lithium iron phosphate. Recommended charge current 50 amps. That would be about 1/4 C, 0.25 C. They say you can charge it up to 1 C, which would be 200 amps. And recommended charge voltage 14.6. I think that comes out to be 3.65 volts per cell, which is pretty high. That's the maximum you'd want to go to, so I'm not going to charge it that high, I don't think. You can get lithium 99% full at a less than that. Cutoff. Yeah, it's the charge cutoff and the recommended charge voltage are the same. So I would stay under that. You don't want your BMS cutting off. Charge cutoff voltage. Okay. I would stay under that. You don't need to go that high. 3.45 volts for balancing. That's good. That's pretty much recommended by a lot of the lithium testers and experts online. And it has to be 50 millivolt different for the balancing to work. So if it gets to 3.45 volts, which is, I have to do the math. I know all these things in my head on 48 volts, but if you get to this, it's not going to balance anything unless there's also a 50 millivolt difference between the cells. And then we says you can take 200 amps out of it. I'll have to look and see if I have anything I can put any loads on that big. Here's some of the other specs on cutout for the BMS. Temperatures, of course, they say down to -5 C, which would be under 32 degrees. That's given a little leeway. Usually you don't want to charge below 32 degrees Fahrenheit, which would be 0 C, 0 centigrade. Anyway, we'll have to look at the app, because that's something that's nice to have on here. And there's info in here on hooking them up, series and parallel. You can go series up to, you can put 4 of them in series up to 48 volts if you want to. Here's the how to get the app and how to use the app. So we'll take a look at the app here. Okay, I have the app running on the phone here. It's an Android phone. Maybe I should go inside to do this because of the glare. But it's called EEBMS. You can look for it on Play Store. And it's showing right out of the box that it's 54% SOC. Here's the voltage, capacity, charge MOSFET on, the discharge MOSFET on, 62 degrees Fahrenheit. It's a little cool outside here. And there's some more features on here, like being able to see all the, it's hard to do this one-handed because I'm not a professional Android person. You go to detail and you have to put in the password. It tells you in there. You have to put in I think it's 3, 4, 6 sixes. 1, 2, 3, 4, 5, 6. And hit this. Hit OK. There we go. It goes to the next screen. Date of manufacturer 9/26/2023. So that was a while back. I guess they've been in transit. No cycle times. It's got the the differential between the cells, the low and the high, and here's all the cell voltages. Of course, you won't see any differences until it gets up to its like absorb, or the very top charge level is where you'll see the main differences. You won't see them when they're under just sitting idle or being discharged a little bit. They're all going to be close, so you won't see any differential until it's up high in voltage or very low in voltage. That would tell you how well the cells are balanced. So it's got all the info a person would want to have to diagnose this or just keep track of it. No data logging though, but we don't expect that. And there's some things for settings and stuff on here, which I haven't looked at too close. Here's the it says calibration or calibrated. I'm not sure what this orange thing means. If it means it's been calibrated or if that's how you calibrate it. So I'm going to try to charge it up and see if it takes, it's about 50%, and if it's 230 amp hour, that means it's going to be about 115 amp hour, or 100, somewhere around that, 100 to 115 amp hours it should take to charge it up full now, and this should climb high. So I'm going to try to hook things up and make it work. I have a charger that will keep track of the amp hours going in. Okay, here's what I'm going to use. Here's what I'm going to use to charge this. I have a ride-in RD6024. Means it'll do 24 amps. And I have it set up here, you can see. I'm going to charge it to 14.4 volts. And it can charge up to 20 amps. These are over voltage and over current protections. And then I have it also set up to turn off at, if it gets to 14.4 volts and 1 amp, it will cut off. And it keeps track of all the current going into it and watt hours and stuff. So it's a nice little power supply. I bought it and I mounted it in this ammo case here. Just a plastic ammo case. I didn't get the power supply with it originally, but then I got it later. So I have the power supply, the AC power supply is in here. This was a 60 volt, 68 volt, 1000 watt power supply. But I also use it, I have it set up so I can use it with my 48 volt system if I'm under, you know, charging. Like this battery, I could charge off my 48 volt pack now if I wanted to. But I'm going to do it this way for now. I guess I'll leave this open just to keep it cool in case it needs any cooling. So it's just coming up here to the leads. So I'm going to turn it on. This has some special battery charging features. It's kind of isolated from the regular one. You'd have to look up the specs, but let's give it a go. Press the on button. There we go. 13.78 volts, 20 amps, and 276 watts. So this theoretically should take about, what, 5 hours? 20, if I have 100 amp hours left to go in it, that's what it's going to take, around 5 hours. So I have another meter here to check everything. I'm going to check and make sure there isn't a voltage drop on the on my wires here. So I'll check that now. So here's what I have on the voltmeter at the battery terminals. It says 13.43, and this is showing what is it showing? 13.97. This is quite a bit different. There's probably a way to calibrate this for that difference. I'm not sure how. But anyway, so far it's been running a little while. 6 amps in there. 6 amp hours in there. So it's going to take a while, but I need to figure out, either turn the voltage up to compensate for this or compensate this, because it's going to shut off prematurely the way it is now. Here's the app. The app says the voltage is 3.385. This one says 3.43 and 20.4 amps in there. This has gone up some, so that's counting. Let's look at the cell voltages. Here's what I don't like about the app. Why, when you go to detail to get to the next screen, do you have to put in a password? That doesn't make any sense. It's a little bit of a pain. And then if you go back to the other screen, then you have to redo it again. So yeah, anyway. Here's the cell voltages. All within 3 millivolts of each other. I guess this app shows the red is the high voltages. Well, that's kind of nice, the colors, and then the low one is green. I don't know if this app will show when it balances or not. We'll have to see if it gets up high enough, if it is more than 50 millivolts different. Let's go back to the other screen. Go back. So it all works, the app works. I'll go get my clamp meter and I'm thinking that's pretty close to the same, since there should be, this is showing 20 amps and this is 20 amps, so. But I'll go get my clamp meter and see if that one's the same. There you go. 3 different meters, 3 different readings. This one shows 18.5. 20, whatever the app said. On the app, when you're in this details page, you can press protect state. Gives you some more details in case there's any alarms or anything. Right now it just shows charging, discharging, but if these other ones were colored, it'd be some kind of a protection or over temperature or something. I don't know what all these mean. And then like I said, the only thing I don't like about this app is that if you go back you go back to the main page and the detail page. And then you want to go back to details again. You have to put in the password all over again, which is kind of annoying. Because why? It's not really anything on there, it's just info. Okay, I'm still charging. 88 amp hours in there, and it's up to 92%. So it's been charging for quite a few hours. Anyway, I might make a part 2 of this video, pending. I've been trying to find a load, and I found this. I have this old Trace 1.5 kilowatt inverter. Somebody gave it to me. I don't know if it works. I think it was taken out working condition, so I've been cleaning it off, and I'll be able to plug a bunch of loads in here if it works, and then load down, see how the battery does. But I need to make some cables for the other end. Here, I got the cables that came off. These are ones that came off of it. Pretty much a mess, so I better make sure this is even a 12 volt. I think it is 12 volt. So we'll have to wait for another day. The daylight 97.7, 96% full. So I'm going to shut it off for today because I'm losing my son. I'll have to pick it up tomorrow or the next day whenever the sun comes back out. Yeah, it's next day. It's cold in here because it got cold out in Wisconsin again. Yesterday I put 5.7 kilowatt hours into heating the place, so it was nice and warm in here yesterday. So I'm going to have to cut off the video. I'll have to make another part 2. Here's the temperature of the battery right now, 41 degrees Fahrenheit. Or for you Celsius people, 5 degrees centigrade. So anyway, it's kind of cold in here. I'll finish charging it up another day, and then by then hopefully I'll have these cables. I'll have some new cables made. Somebody just cut these off. I'd have to find some big lugs. Anyway, so I'm gonna end this video, make it up, and in case you're curious, here's some of the 48 volt system I've shown in other videos. This is a Outback 3500 watt inverter, Midnight Classic, and this is a Midnight Hawke's Bay, and I have a PV bypass to that heater. And all the lithium batteries are in this insulated box with a heater in there. Anyway, we'll catch you next time.